Welcome to my vlog on big data and cybersecurity. My name is Lim. I'm a computer scientist, an educator, and a software engineer. Now, today I want to talk about a potentially contentious topic, and it's about whether you should use a common data model or not. In last episode, I talked about how to transform Zeek logs in its raw schema, raw format, into OCSF format. Now, the question is, well, should you use a common data model like OCSF or not in the first place? Well, if you're using legacy SIMs, oftentimes that decision has already been made for you. The SIM will actually decide. If you're using Databricks Lakehouse, you have a lot more flexibility. And in this, cost-conscious macroeconomic climate, this might be just something you want to think about because it has a lot of cost implications as well. So let's dive right in. Should you use a common data model? Question mark. Yes. Well, you have additional options. You want to do schema-on-write or schema-on-read. If you do schema-on-write, you're going to have to do ELT pipelines to ingest data and transform them into the common data model. If you're doing schema-on-read, you're going to have to map the data to the common data model at query time. This is usually done using views. Or if you're not going to use common data model, or you're just going to stick with the source schemas, which is perfectly fine as well. And regardless of whether you use common data model or not, you still have the option to speed up all your IOC searches with summary tables, which I've talked about in the previous episode. Or you can use graph data models to do relationship discovery. And this is something that I'll talk about in a future episode. Let's dive right in with the pros and cons, right? So with schema-on-write, well, there is cost involved. You have to maintain the schema mappings from the source schema to your common data model. And if the source schema changes, it might break your pipelines or queries. However, the process that is really good for your tier 1 analysts, for example. They just need to deal with one common data model, and they have to deal with the source schemas. If you're doing detection engineering, it's going to simplify your life as well. A much smaller detection query set. Because imagine this, if, say, for authentication, you have both Okta data and Azure AD data. Now, for the same detection query, now you have to write a query against the Okta data and a query against the AAD data. If you have that all normalized to, say, OCSF authentication table, then you just need to write one query against the authentication table that handles both Okta and AAD. That's the beauty of common data models. Now, if you don't use common data model, well, the beauty is you don't have to maintain any mappings, which is fantastic because maintaining mappings is tedious work and hard work. And possibly you might lower the cost for your ELT pipelines. You don't have to, you don't need pipelines to actually transform the data into the common data model. But your analysts will have to deal with the complexity and variety of the source schemas. They deal with more tables, different schemas for each data source, more queries to maintain. Now, back to schema-on-write, you do have to maintain ELT pipelines to transform data to the common data model on ingest. Again, from a Databricks point of view, we do recommend the medallion architecture where you ingest the data as raw in its original format, and then you'll be transforming it into the common data model. That will be the silver layer, and further aggregation will get you to the gold layer. And there is definitely a cost associated with that in terms of compute, ops, and dev for the ELT pipelines. For storage, which is probably not, storage is cheap these days, not too big of a deal. And when the mapping involves your older data, typically will not get reprocessed. But the user experience is great for analysts. Right? If you do schema-on-read, you're going to be mapping the data to the common data model at query time using views. This will have an impact on query performance due to the need to execute the mapping logic at query time. And you still need to maintain the schema mappings in the view definitions. But mapping evolution is easy. Like any changes in your mappings or any changes, if you need to debug your mappings, No problem. Just change the view definitions and instantly everything is correct, right? No issues with data in multiple schema versions either, right? Because you never materialize those. So these are some of the options that you have. And if you want to use a graph data model, graph data models are really good for relationship discovery. Yet another sort of data model that can coexist with all of this. Now, with all these options, how do you reason about this, right? Essentially, you have to make a trade-off between costs and operational efficiencies. And operational efficiencies is tied to your risk and posture. And really, on that front, you want visibility into all security data. You want fast queries for all security data. You want ease of data exchange and sharing. And so that your analyst will be efficient, you want your developer to be efficient, you want the operator to be efficient as well. But all this comes with a cost in terms of compute, in terms of developer and operator cost, total cost of ownership, storage. And again, if you think about it, right, maintaining pipelines, maintaining schema mappings, all those require cost, right? But not all data are equally important to risk and posture. Some data may be infrequently queried by analysts. And so maybe for those data, you may not want to materialize them into common data model. And with the Lakehouse, you have a lot more options. For example, right, we talk about the medallion architecture, but hey, you know what? For infrequently data, maybe we don't even want them to be in the bronze, right? Maybe we just keep the data in its original form, in its new line delimited JSON format on cloud storage. And this is exactly what I'm going to show you how to do with this notebook. Remember the Zeek logs that I showed you in the OCSF episode? I just keep them in DBFS, which is again cloud storage. You can also use just an explicit S3 location. I kept them in DBFS in its original form, and I create a table using JSON and specifying that location. And now I can actually query that data in its original form in new line delimited JSON. I can write my queries against them. They may not be as performant as in Delta format, but hey, if I need to save money and I don't need to ingest all of this into Delta, maybe that is acceptable for you, right? Maybe this is something that's infrequently used, so that is a trade-off that you can make. So the Lakehouse provides lots of options that lots of knobs for you to navigate this trade-off. So back to this question, do you use a common data model or not? Well, I would like to hear from you. So contact me or comment in the LinkedIn post or the YouTube post, and would love to hear your specific situation. Thank you very much. See you next time.